Hi everyone! This video looks at a strong acid titrated with a strong base and will focus on the pH calculation before the equivalence point. If the titrant volume in the problem is more than 0 milliliters, then we have to set up a millimole table. The E row of our millimole table tells us where we are on the titration curve and guides us as to how to calculate the pH from that information. In this millimole table, we are only looking at the E row. Here, we see that the H plus is greater than 0, which means there is some remaining, but the hydroxide goes to 0, which tells us that it is used up. This situation puts the reaction progress in region 2 of the titration curve, which is before the equivalence point. To calculate pH before the equivalence point, we first have to calculate the H plus molarity. We get this by taking millimoles of H plus from the E row and dividing by the total volume. We get the total volume by adding together the milliliters of acid and the milliliters of base given in the problem. Once we have the H plus, we can calculate pH directly by taking the negative log of the H plus. So let's work through an example. Our NaOH titrant in this problem is greater than 0 milliliters, so we know we need to set up a millimole table. So first we'll calculate the millimoles of each reactant, then we'll set up the table. First we'll calculate the millimoles of our H plus, and we get this by taking our 10 milliliters and multiply by the given molarity, which is 0.04000 moles of H plus over liters of solution. I've written just the H plus as the net ionic form of the acid, just because it's a little bit easier when we get to the millimole table. Units will cancel, so we had started with 10 milliliters of solution, so liters of solution will cancel liters of solution, and we're left at this point with the milli and the mole. Taking a look at sig figs, we have 4 sig figs in our volume, 4 sig figs in our molarity. That will leave us with 4 sig figs in our millimoles. So doing the math, we have 10.00 times 0.04000 rounded to 4 sig figs gives us 0.4000, and that's millimoles of H plus. Doing a similar calculation for the hydroxide, here we're starting with 7.62 milliliters of solution multiplied by the hydroxide molarity, which is 0.03125 moles of OH divided by liters of solution. Again, the milli doesn't cancel, it's just the liters of solution. Here, our sig figs are only 3 for the volume, 4 for the molarity. So these millimoles will be rounded to only 3 sig figs. So for the calculation, 7.62 times 0.03125 rounded to 3 sig figs gives us 0.238 millimoles of hydroxide. Now we can set up our millimole table. We start by writing our net ionic equation at the top, which is our substance, H plus our titrant, OH minus, going to water. We'll set up our rows, initial change end to end, and note that our units are in millimoles. Because the water is a pure liquid, it doesn't enter into our calculation, and so we just draw a line through it. For our H plus, we had 0.4000. Hydroxide, we had 0.238. The change row will be subtracting the smaller number, which will be the 0.238, and we subtract that from each reactant. So we put a minus 0.238 for both of the change rows. The hydroxide goes to 0. We have to calculate the H+, which is 0.4000 minus 0.238. Because this is a subtraction, our sig figs will be rounded to the fewest decimal places, which in this case will give us 0.162. The next thing we do is calculate our H+ molarity, which we get from our 0.162 millimoles divided by our total volume. And our total volume comes from the 10 milliliters of acid plus the 7.62 milliliters of base. Be careful with the significant figures with the volume addition. Notice that they both have 2 decimal places, so that means that our total volume will also have 2 decimal places. I'll just rewrite this, 0.162 millimoles divided by 17.62 milliliters. Now in this case, it's just the millis that cancel, leaving us with moles per liter, which is molarity. Taking a look at our sig figs, we have 3 sig figs in the numerator, 4 in the denominator, so our molarity will be rounded to 3 sig figs. Doing the calculation, we have 0.162 divided by 17.62, rounded to 3 sig figs, gives us 9.19 times 10 to the negative 3 moles per liter, or molar. And that is our H+. Now we can calculate the pH. pH is negative log of the H+ molarity, so negative log of 9.19 times 10 to the negative 3. We don't include the units here. We do have to be careful with the sig figs because the rules for logs and antilogs are different than our other math operations. With logs, you take a look at the sig figs in your value, and that becomes the number of decimal places when you've done the calculation. So we'll take the negative log of 9.19 times 10 to the negative 3, and rounding to 3 decimal places gives us 2.037, and that is our pH.